Hi, everybody. As Vicki said, my name's Heather Urquhart, and I'm a senior aquarist here at the New England Aquarium. Been here for about 19 years, working with the penguins. And it's my pleasure. Tonight we have a great speaker, and we at the aquarium are especially excited, and the penguin department especially excited to welcome Alan Clark. Alan currently works with Dee Boersma out of the University of Washington on the behavioral ecology of Magellanic penguins. Unfortunately, we don't have Magellanics here, but close cousins, the African penguins. His career path didn't always involve penguins. He holds undergraduate degrees in religion and music education, actually. He taught music, and he performed nationally in theater, opera, and musical comedy. So later we may be able to get him to do a little song and dance, or I don't know, if you ask nicely, perhaps. When he returned to school for advanced studies, he earned a master's degree in natural resource policy and a law degree. And the legal questions can be held till the end, any of those. But it was while he was studying law and policy in New Zealand that he had his first penguin encounter, and it was with the yellow-eyed penguins in New Zealand. And if you've ever seen them, they are make quite an impression, and they have quite a song that is somewhat you just will never forget it. And when he returned to the States, he really couldn't get the idea of penguins out of his head, and it was at that point that he left his law career and began pursuing a degree at the University of Washington with Dee Boersma. And his specialty is the role of vocalizations or songs of the Magellanic penguins in individual recognition, female mate choice, and breeding behavior. So this evening's talk is the penguin songs, the behavior and conservation of Magellanic penguins. And please join me in welcoming Alan Clark.
Turn this off first. Okay. All right, well, thank you so much for coming. I'm excited to talk to you tonight about penguins. And let me get this up on the screen here. There we go. Okay, I think we're ready now. Okay, and so tonight I'm going to tell you about three general areas. First, I'm just going to give you some basic history and biology of penguins in general, and then focus a little bit more on the species that I know most about, the Magellanic penguin, the hero of tonight's stories. And then I'm going to talk to you specifically about my research on penguin songs. In fact, if I had to, with my various careers, had to label myself, I'd like to call myself a penguin songologist. And then finally, I want to talk a little bit about penguin conservation and the threats that are facing penguins worldwide. So then this is our hero species for tonight. There are three species at the New England Aquarium, and they're wonderful. And if you've never seen that exhibit, you really must. These are just lovely creatures. And they're part of one family. And for those of you who are taxonomists or that like to organize things, a family is a taxonomic group, and all penguins are in the same family. And there are 5 genera, and there are 17, 18, 19, 16, 14, 15 species, depending on which taxonomist you talk to, because taxonomists can't possibly agree, or no, they wouldn't have jobs. And so here you see a list of 17 species. And this one is a little more organized, and it has 18 species. And the difference, you'll see, is this one right here. This is the little blue penguin, which is here. And this one has a white line around the outside. And so some people consider that a separate species, the white flippered little blue penguin. And you can see that, the groups here. You've got the famous ones, that were made most famous recently by March of the Penguins, the Emperor and the King. And then, of course, my sentimental favorite, the yellow-eyed penguin. And then you have the stiff-tailed penguins in the middle, the chinstrap, the gentoo at the bottom, and the Adelie in the middle. And then you have all those ones that look alike, the crested penguins up at the top, which the rockhoppers here are part of that group. And then you have the Spheniscus, the group of 4 that really do look like they're in tuxedos. And the one I study is the Magellanic penguin. And it's called the Magellanic penguin because when the first wide-traveling European, Magellan, was wandering around, he was coming down the east coast, the Atlantic side of South America, and they discovered these strange creatures. And so the first European to see a penguin. And so it was called the Magellanic penguin. And that's how it got its name. Penguins, most of you know this and should know this, but you see them mostly in the southern hemisphere. And the holiday season is arriving, especially Christmas. And I don't know if any of you every year pay any attention to those Canada Dry commercials. They have the polar bear hanging out with the penguins. If you know where polar bears live and you know where penguins live, you realize that Canada Dry is a fantasy world. Most people think about penguins on snow and ice. And you see these, Adelie penguins on this ice floe, and I can say they're Adelies because you can't prove me wrong. And then this chin strap, it's very typical what you might expect to find. And then Gentoo penguins, marching in a line back to the sea. Typical penguins, snow, ice, icebergs, Antarctica. And they travel great distances. I'm assuming, how many of you have seen March of the Penguins? Yeah, most of you. So I'm not going to give you a lot of detail about that because that was an incredible documentary that was very, very factually based. You've seen this kind of movement before. And this is called tobogganing. And basically, you just lie down on your belly, and then you push with your feet, and you steer with your flippers or wings. And then you get a drink, and then you keep going. All right? I'm just going to show you a few video clips to get us going here. And these are Adelies again, and showing that it's not always easy to get to your nest. This is an ice cliff. And then keep a watch over on the right. It's my favorite one. Obviously taken from a boat. There we go. And it made it. All right. I have one more of these clips, and just because they're so cute. I mean, they're pixelated. They're bad videos, but they're fun. All right. And these, again, are the most common penguin in Antarctica, the Adelie penguin. Oh, wait. There's my little hand. And they're hanging out. They're not doing much. Everybody's just kind of looking over the edge. Some go up to the front, look over the edge, and then walk to the back of the line. And I don't know. And then they wait, and not much. And then somebody goes. And then somebody else. All right? And then it's a free-for-all. All right? And everybody goes, did they go? Did they go? Yep, they went. And then they all go. All right? Okay, so this is free form. I'm pretty informal. Does anyone know why they're just looking over the edge and nobody goes, and then when somebody goes, they all go? Yeah, leopard seals. If you're the first one and there's a leopard seal down there, you're toast. All right, you don't want to be first. But if somebody else is gone, everybody wants to go because, the leopard seal can only get one. All right? So if 70 of you go at once, 69 of you are safe. All right? Okay. And that's a common strategy you see in nature. Just overwhelm your predator. All right. Okay, but back to our hero, the Magellanic penguin. You see no snow. You see no ice. There are no icebergs. You see no people in orange suits that are really large. All right? This is a desert. All right? And this is the home of the Magellanic penguin. This is a beach scene with the species here. This is the African penguin. And just having a lovely day at a white sand beach. All right? No snow again. All right? And this is Punta Tombo, where I've been doing most of my research. It's a scrub desert, much like you would find in the west of the U.S. And you can see some of the little, shrubs in the background. And you notice that there are these, dips in some of the penguins. You only see half of them. That's because they're in their nests, all right? They actually dig burrows, all right? They don't nest on rocks. They actually dig a hole in the ground, all right? And so I just want to talk briefly about nests. And this is what I call bungalows. They're little apartments dug into the side of a hill. So, when you come out, and penguins, when they go to the bathroom, they come out of their nest, they turn around, very sanitary, and they let go with a large stream. And so you'll often see these beautiful marks on the sides of things. And you can tell what they've been eating by the color. I noticed in the exhibits here at the zoo, they're all white, which means they're eating high-quality fish. But if you're stuck with squid, you're going to have kind of a gray, blackish color. And if you're eating shrimp, you have a beautiful orange-peach color. All right. But other species, the ones that are more common, have rock nests. Most of the Antarctic species have rock nests, and they're famous. I mean, how many of you have heard that penguins like to steal rocks from each other? Okay, a few of you have. That's a very common understanding, and it's true for these. They love rocks, and there's actually a rock shortage in our world, especially in our Antarctic world. And so they're constantly, and rocks are not only a sign of prestige. So your mate, if you're a guy, your mate wants you to be stealing rocks. All right, and they're good. They provide drainage and separation. Your eggs don't roll down the hill. Rocks are good. And what a famous researcher, I think Steve Kress did, is he did this very famous experiment. On one side of an Adelie colony, he put he painted all these, of red rocks. And on the other side, he put a big pile of blue rocks. And then he came back a week later, and the blue rocks and red rocks were distributed in a completely random pattern throughout the entire colony. And it was a mosaic that changed every few minutes as penguins stole them from each other. All right? But you can see in some of these pictures, they do provide you elevation, and they do hold your egg into the nest. So they have some utility. Now, some penguins just use a grass nest. You see here a little blue on the upper right. All right? You see a crested penguin pair and their little chick, just, kind of carved out among the tussock grass. And then there's a nest with a Magellanic penguin that is so deep in the grass that all you see is the head poking out. But that's actually a penguin nest in there. Now, as you also know, if you've seen March of the Penguins, that not all penguins have nests. And it's fascinating. The king and the emperor penguins actually just raise their eggs and their chicks right on their feet. And they move around and have no need of nests. This is in here because this is just cool. All right, this is a penguin mouth. And my mother, I showed this to my mother. She was very proud because it's proof I have stopped biting my nails. But aside from my hygiene issues, you notice that the roof of the mouth of this bird is all these barbs. And they're not pointing down, and they're not pointing out. They're pointing in. And that structure at the bottom is its tongue. And it's also covered with barbs, and they're not pointing up or out. They're pointing in. Why would you have a mouthful of barbs that point in? Yeah, exactly. It holds fish. Fish are slimy and slippery. I don't know if you've ever tried to grab one. All right? And so when a penguin bites a hold of a fish, if it wiggles, there's only one direction it can go, and that's with the grain of the barbs, which is down into the stomach. All right? But isn't that a cool picture? You also can see a penguin eye. And with Magellanic penguins, you can get a general idea of their age by the color pattern in their eyes. And very old birds have very, very dark, plain eyes, but young birds will have all kinds of beautiful colored rings and circles and things. It's not exact, but it's a way to tell young bird versus old bird.
Are those barbs really hard?
They're pretty hard. They won't pierce, but they're pretty hard. Yeah. And if you have questions, there'll be time at the end, but you can also interrupt me at any time. So please do. All right. Now, penguins are classified as a bird that is flightless. And I take umbrage to that. How many of you have gone over and looked over in the penguin exhibit and looked down here? All right. So you may know what I'm talking about. Now, any of you who are physicists or have taken physics in past, you may understand that both air and water are fluids. Now, air has a lot of gas, but it's nonetheless a fluid. And the properties that control fluids are the same regardless of the density. And so I've done some experiments with penguins in wind tunnels that tells me about the effect of drag that the devices we put on them to track them by satellite, what effect they may or may not have on the birds. And you can do it in a wind tunnel, you can do it in a water tunnel. It doesn't matter. But penguins, I assert, actually fly. And this is a video of some Galapagos penguins. They're doing a little fishing here. Look at them fly. Yeah, if that was air, you'd be saying they were flying. And they, unlike some birds, they dive very deep. They dive hundreds of feet deep for their prey. And king and emperor penguins can go incredible distances in deep. But they get there using their wings. They fly down. As opposed to a cormorant, which also goes to incredible depths, but kicks its way down. It uses its feet to get down to those depths. But penguins are not flightless. Okay, back to our heroes. A little bit about the Magellanic penguins. I just want to point out that you see there's this little stainless steel band on this flipper. And that's how we ID penguins. That's stainless steel, and we put them on them when they're either juveniles or adults, and it tells us who they are in their history. This is number 49316, which means it was the 49,316th penguin we banded at our area. And to date, we've now banded over 55,000 penguins. It's one of the largest banding projects in the world, and it's allowed us to gain a tremendous amount of information about this species. And this is how we gather this information. These are biologists. Over on the right, you have Dr. Ginger Rebstock, and that's me, looking younger and slightly thinner. But this is what typical gear for what we wear. And you'll notice that we have knee pads, all right? And that's because we spend a lot of our days on our knees looking into burrows, weighing and measuring things that are on the ground. You'll also know we have gaiters on our ankles. Gaiters are usually used by people who ski. But again, we have no snow or ice. And the reason we use gaiters is because we try to minimize the number of penguin flea bites that we get. Most penguin species have a species of flea that is their very own specialty, that specializes on them. And there are some years that the penguins arrive at the colony after the biologists. And those fleas are geared their life cycle to the arrival of the penguins. So if the penguins are late and the biologists are early, we're not first choice, but we're good enough. And you also see that we've got vests, and which carries things like our scales and our compasses and our GPS. I weighed mine one time, and it was well over 20 pounds of gear that we carry around with us normally. And then in my right hand, you see there's a couple of stick things. And in one of them, it's a yardstick, which we've duct taped a green bean can to. All right? And the other one is a piece of rebar that we've bent into the shape of a little shepherd's crook. And how in the zoo here, you walk up to the penguin and you pick it up. All right? Magellanic penguins, they actually don't really let you do that at Punta Tombo. They see you and they generally go by. So what we do is we sneak up to them and we put our little shepherd's crook around their ankle, and then we pick them up by the back of the neck like you would a cat. Right? Because these birds, if you can see, especially the Spheniscus species, have hooked bills like an eagle. And anybody who's worked with a Spheniscus species has scars. And I can assure you, I see some of the penguin workers, they all have scars. And some of us have them in frightening places. But what we do then to get the eggs and the chicks out of the nest in order to weigh them, measure them, tag them, is we put that little egg cup under the adult, and then we scooch the egg into the cup, and then we pull it out. Because these penguins are likely, they seem to be, they will naturally attack anything going in and out of their nest while they're incubating or brooding chicks. Now, this is a different experience for those. How many of you have been to Antarctica? Any of you? There's a few. Those penguins, and you see this, people walk up to them and pat the penguins on the head, and they're not afraid at all of people, all right? And that's because in Antarctica, there were no natural land predators for these birds. And so there was no need to develop defenses or fear of anything that was walking on land. And they have no fear of people. Unfortunately, about 12,000 years ago, humans came down through the Americas, made their way to South America, and found that these nesting penguins were delicious and easy to target, and pretty much wiped out all penguins on the land masses. And so those penguins quickly evolved a very healthy fear of people, and that still exists. And I'll talk a little bit more about that later. But that's how we get our information. And here, you see just a couple of researchers. One has a new chick that he's putting a little fiber band on. You see his egg cup in front of him. And also you see on the right, Jenna Sigmund, who works here at the New England Aquarium and has spent some time working with us down in Argentina. And she's returning a medium-sized chick back to its nest. Nice shot, Jenna. So here's just a little bit about the penguins. And here this picture is of a pair, but it's called allopreening. They're basically cleaning fleas off each other and, it's sort of a bonding kind of activity. Magellanic penguins are on both coasts of South America, but the largest colonies are on the Atlantic side and also in the Islas Malvinas or Falkland Islands. Where I do most of my research is Punta Tombo. We do research on a number of colonies along the coast there. But Punta Tombo, which is the site of the largest penguin colony outside of Antarctica, we've got about 500,000 penguins in this one colony. And this is a shot from one of the space shuttles. And what this, and it shows you, Punta Tombo is the middle of these three things, but you can see that these are actually lava tongues, from old lava tongues that came down from the Andes Mountains. And this point, Punta Tombo, is where the penguin reserve that we study at is found. So how the season starts is, as you know, penguins spend most of their lives at sea. And then in September, the first week or two, the males make their way south somewhere. They probably winter, we don't really know, somewhere northwest of Rio, somewhere off Brazil. Every now and then someone will catch one in a fishing net, but we just don't know where all these millions of penguins go. It's quite a mystery. But they find their way back to Punta Tombo, and they usually find their way back, the males, to within a few meters of where they were hatched. And then they try to set up a territory. It's not always a happy thing because these are really important. And the males fight for these nests, and they improve them. Because what it turns out is females are most interested in a quality nest. The male, well, males come and go, but you got to have a good nest. It's real estate, real estate, real estate. The number one predictor of whether you're going to be successful at raising chicks or not is, aside from whether there's any food that comes down, is whether you have a good nest or not. All right, so it's pretty important. And the fights can be pretty nasty sometimes. About a week and a half after the males get back, the females get back, and love is in the air. All right? And so these males start calling and calling. They call all day. They call all night. And what you see sometimes is, because I'm out there a lot recording birds and watching them, is you'll see all these males calling, and a female will come walking through the colony, and males are calling all around her. And all of a sudden, she'll lift her head up, she'll look around, and she'll make a beeline to some male she can't see. She ignores him completely and looks in his nest. All right? And then if the nest is decent, she comes out and takes a look at the male. And then sometimes she'll stay. But vocalizations seem to be very, very important to these birds. And then eggs come. Now, this is not a Magellanic penguin, but I thought it was only fair to keep including every now and then other species. I don't want to be speciest. This is a chin strap, all right? But about 10 to 12 days after they copulate, the first egg appears, and then 4 days later, the second egg appears, all right? And by the time the second egg appears, these males have been on land for about 4 weeks to a month or more. They haven't eaten, they haven't had anything to drink, so they've lost up to a third, almost a half of their body weight. They don't look so hot, they're dirty. And so when that egg drops, they're out of there. All right, they've got to go back to sea to refill their supplies. It's not as extensive, this fasting, as those larger penguins, the emperors and the kings. But for these smaller guys, it's quite an ordeal. And so the first thing they do when they get to the water is they take a nice bath. Try to get rid of some of those fleas, clean up, drink a lot, and then they head out to sea. And these males then are gone about 2.5 weeks. And what happens is, at least the Magellanic penguin, I found out that the preferred food here at the zoo is not anchovies, which shocked me and is wrong. But Magellanic penguins in the wild prefer anchovies, all right? And it's also Humboldt penguins on the other side prefer anchovies. I mean, penguin food is anchovies for these Phoniscus species. But here they like capelin, which is, I understand, is like Norway. Makes no sense to me, but... So the anchovies are migratory. So they're coming down from Brazil, just like the penguins did, but they're further behind. And so the penguins, the males, when they leave the nest after leaving the eggs and the female on the eggs, they have to go back north. And they travel great distances, sometimes up to 1,000 kilometers during a 2.5-week period and back just to find some anchovies. So think about that next time you order a pizza. Now, so after... The males return after about 2.5 weeks, and the females go to sea then. And they're going about a week and a half, and then they keep switching every few days, every other day, until the chicks hatch. And the chicks hatch at about day 38, the first egg, and the second hatches about 2 days later, about 40 days after it was laid. So they don't hatch exactly the same amount of days, and it's because the females probably don't incubate that first egg very much until the second egg shows up. All right? So, and then these are just cute chick pictures, all right? And I just want to point out a few things. On the upper left, look at that. Those are kind of chubby little chicks, but look at those flippers. Those flippers are no bigger than the day they were born, all right? These chicks are probably a couple of weeks old, all right? But think about it. From an energy standpoint, if you're on land, why would you put any energy towards your flippers? All right? It's the last thing you need to worry about. So what grows first? Big mouths and big feet. All right? You got to be running to mom and dad to get the food. All right? And the last thing that grows, then, out come the flippers. It's like they pumped them up or something. They just come out in a few days, it seems like. All right? And then on the right, you see that we call this water balloon. All right? But this one's had a nice big meal. All right? And they can eat way more than their body weight in one feeding. But you see there's a line down that. You see that line down that belly? And you see the lower one on the right? Now that's a nice good, I call these the pears. All right? It's like they haven't really gotten their adult form at all. They're just fat. All right? And so they look like a pear. All right? But it's also got a nice big line down the middle of its belly. And what that is that's a bare patch. And that bare patch, it's on both males and females, and it's called a brood patch. Because when they get to be adults, parenthood in Magellanic penguins, and almost all penguins, is 50-50. It takes 2 birds to raise a chick. And so, but penguins are the most insulated bird of any species. They have well over 100 feathers per square inch, because you need it if you're going to live in the cold water all the time. You have to be waterproof and highly insulated. The problem is, if you're completely insulated and you lay in an egg, there will be no heat going to that egg, and that egg will never hatch. So what they have to do is they have a bare patch so that they can just open up and lay on their eggs. And that bare patch is just long enough so 2 eggs can lay end to end on that brood patch, and that way they can provide heat to their eggs. And then they get to the ugly adolescent phase. And you can see this over on the right. They kind of look punkish. They start losing, they're pretty down, and they get their juvenile feathers. But they're cute. Really cute. And that's just in there because it's cute. Okay, and then one day, these chicks, it takes about 3 months to raise a chick, as opposed to a couple of weeks to 3 weeks for a songbird. That takes a long time to raise a penguin chick. And on average, a pair of penguins raises a half a chick a year. I mean, you have to do some math. That means every other year they're successful raising one of the 4 chicks. All right? It's a tough life. All right, and it's hard sometimes when you're out there working because you know that 3/4 of all chicks aren't going to make it, on average. But many do. All right, and this is what they look like on the right. That's a juvenile penguin. No, those are pigment spots. In fact, some people identify these species by their spots. And Magellanic penguins is a sphenisca species, and there are 4 of them. And they have the fewest spots on the breast. But a lot of researchers, they have pictograms, and when they see a penguin, rather than band it, they do the dots. And you see this bird has a couple of dots on it as well as underneath the flippers. That's a way that people, it's like a fingerprint. Excellent question. All right? And what these chicks do after about 3 months, if they've been fed well, they get up one day, and I'm anthropomorphizing, and I do this all the time, and if some of you are really scientifically oriented, I'm probably going to annoy you, but I can't help it. All right? They get up out of the nest, they look around, and they say, I think it's a good day to fledge. Without looking back, without saying goodbye to mom and dad, they just go. And they just walk into the water, and if something isn't there to eat them, which often happens, they make it, and they go out to sea. And they don't come back to land for 9 to 12 months. And when they do, this is what they look like. And then they will hang out, and they will molt into their adult plumage. Okay, and the final thing in this area I want to talk about is some of my research. I've been researching penguin vocalizations. I like to call them songs that it seems to upset the people who study passer and birds, the tweety, tweety, tweety ones. And maybe you'll agree with me that maybe these aren't songs after you hear them, but I think they're beautiful, and I'm going to call them songs. All right? And so this is the beach at Punta Tombo. Remember, there are 500,000 penguins here, and when the breeding season starts, all these guys are calling, and oops, I forgot to go back and turn that on. So I'm just going to slip right here. And so this is what it sounds like, only it's deafening. You can't hear yourself sleep or think, and especially when they decide they're going to live under your trailer. And you pray and hope that they get a mate soon, because if they don't, they're going to keep calling. I've lost many, many, many nights of sleep because of lack of love in male Magellanic penguins. Now, this is what I call a calling circle. It also looks like a choir rehearsal. All right, you've got the guy, way in the back. All right, and it's this classic position, and you'll see several of these slides, but you'll see the bill is straight up in the air, and the flippers are out to the side, and it's not like a crucifixion scene. It's more of they're trying to get, if you talk this way, the people behind you, they can't hear you nearly as well. All right, but if you put your head straight up, you get more of a 360 degree. And if you're advertising, you never know where love's going to come from. You don't want to miss it. All right, and so also you put your arms out because you want your lungs to be as, like have you ever seen opera singers? They do this kind of thing. Or runners, you have to keep your rib cage expanded so that you can breathe easier and more powerfully. And they're doing the same thing. They've got their arms out so they can really bellow. All right. And what we find in these calling circles, they're mostly young males. And it's like they're trying to learn how to sing right. And so somebody starts, and then the others kind of walk over and look at it, and they may try for a while. And so I don't know if this is a choir director and the assistant choir director or a critic, but they do this a lot on the beaches. And this is how I do my studies. You see, this is you'll notice there's some flags above the penguin, and that means this is one of our study nests. You'll notice there's a flipper band. There's a band on that penguin, so we know how old that bird is. And then I'm hiding behind a bush with my microphone and tape player, trying not to disturb it to get natural calls. But you'll also notice that it's a shotgun microphone, so it's very narrowly focused. But when I first went down there, I had an incredibly expensive, glorious piece of equipment that someone lent me that's top-notch, world-class. And it didn't work because if any of you have ever been to Patagonia, you'll notice there's something that Patagonia is well known for, wind. And so when I would record a penguin, I would get this. All right. So I got a cheaper microphone, and I went to town, and I bought a toilet seat cover. Actually, it was a bidet cover because it's South America. But, I mean, you get the same idea. And so then I sewed the bidet cover over my microphone, and it worked beautifully. And I used this for 6 years. And so once I would get these recordings, I would take them inside, and I would scan them into the computer so that I could begin analysis. And you can see we really aren't very tidy in the field if you look in the background, but it's a field camp. And what I've learned is Magellanic penguins don't have a lot of different call types. There are some basic ones. There's the advertising call, and I don't like these terms, but all the literature does this. It's called the ecstatic display call. But it's basically, the birds are advertising for love. And then you've got what the pairs do, the mutual display call. It's a duet. All right? And then you've got calls that the birds give when they're fighting. And fighting can be between two males, can be between two females, or it can be between two pairs. Males and females usually don't fight, but sometimes one pair will beat up another pair. And then there's contact calls. Are any of you birders? You like bird watching? And a lot of birds have a contact call. Well, penguins have one too. It's just a single note, and it's a sort of where am I, where are you? And that's how they keep in touch. It's usually given at sea. And then finally there are the calls that chicks use when they're begging for food. And I'm going to focus mostly on the advertising call and the duet for most of my research. And again, here's some of these males in their classic advertising position, bills up, flippers out. And this is what the structure I study. For anyone who studies anything audio, the top part of this is what's called a spectrogram. And it's just a visual representation of the sounds. And you've got kilohertz on the up and down line, the axis, and that's just frequency, the pitch, how high or low it is. All right? And penguins actually speak about the same range as the human adult male does. And so male penguin's voice is about the same, rather than way up here or way down there. It's about the same place as my voice. On the bottom is called a waveform, and it just shows you where the power of the call is, where the important, powerful parts of the call are. Now, I'm going to play this call. And if you're careful, you can actually, follow the bouncing ball. There isn't a bouncing ball. You'd have to imagine the bouncing ball, but you can follow along. And the last two notes cuts off, but isn't that beautiful? That is a song. Okay? And if you were a female penguin, you might or might not think that was hot. All right? Okay, but there's several structures in here I want to point out. You see those first lines, those huh, huh, huh. We call those huh notes. And those big long ones, those brays, we call those brays. Now I'm actually studying something that I haven't found anyone else studying before, but I'm studying this form structure and patterns of the. Did you hear those? Like a donkey, and then right before that, they're like, all right. I'm studying those. I call them inhale squeals. All right. These are scientific terms. You may want to write this down. All right. And I'm finding that you can. There's a lot of information in those inhale squeals. Now, I'm going to point to another slide here, and talk a little bit more of that in a moment. But first, let's talk about the duets. Here, you've got a lovely pair. And male and female penguins in Magellanics are just slightly different sizes. Males are a little bigger. Usually their foreheads are a little steeper. Their bills are a little deeper. And they're just a little bigger overall. And here you can guess which one is the male and female based on what I just told you. And you see that pink you've been seeing on a lot of these birds? You might wonder what that is. Those are not pink feathers. They have no pink feathers. And what that is that skin where their white feathers used to be. And what happens when the penguins first arrive in September? They all have feathers here. There is no pink. And then immediately they begin losing all the fur from around the front of their face. And that pink appears. And now why they do that is, people arm wrestle and write nasty notes to each other in the scientific community about what that means. And one of the theories is that it makes you look sexy, all right? Because you're showing bare skin and it shows your blood flow, all right, that pink. So if you don't have a really nice, deep, rich, maybe you're anemic, or maybe you've got parasites, all right? And that's true in a lot of birds. A lot of birds have bare patches for that very reason. That's one theory. The other competing theory is that it helps them cool in the desert climate. It's hard to lose heat. And another theory is because you can't thermoregulate if you don't have feathers, it shows how healthy you are. That I don't need all my feathers and I can still be a penguin. And so those are competing theories about why they have those bare patches. Right? But they're doing a duet here. And what these duets are, they're overlapping. One starts, the other overlaps it, and at the end they synchronize their notes. So again, see if you can follow along on this lovely duet. Now, I don't know about you, but I could feel the love in that call. All right. And they do this call usually when they return at the beginning of the breeding season because they haven't seen each other in months. The males and females don't seem to travel together. So they haven't seen their mate in 7, 8, 9 months. And then when they exchange at the nest, they do this lovely little ceremony, which I've been studying and writing about. And then sometimes they just do it for fun. All right. Or if they're really mad at their neighbors, they'll do it too. But it's a versatile call. All right, because I've been interested in these calls, I've been wanting to know if maybe penguins tell each other apart by their voices. Now, there have been several studies that have shown, and pretty good ones, and they don't all agree, but many of them show that. How many of you think penguins all look alike? Well, this is a tough crowd. Okay, all right. Well, it turns out penguins do too. They don't seem to be able to recognize each other just by looking at each other. All right, it seems like they use vocalizations, and so I want to discover how that works. And so remember, this is one of those male display calls. And so what I did is I measured 30 different parts of each of these calls, and my arm hurts. And I'm getting close to 50 to 60,000 measurements that I've made on these calls to study for my research. But I want to point out one thing on this. I mean, some of them, like T1 there's just the total length of the call, and some is, you don't need to know any of this except that I studied a lot of things. But do you see these? These are those inhale things. And you notice that instead of this here is like the bass call, and then just like human voices, there are harmonics. I don't know if any of you have ever had a voice lesson or a choir, and the teacher is always telling you to sing into the mask or sing up into your head. That gives your voice more harmonics. And that's those bands that you see here. And that makes it carry further and be more resonant. All right? And so penguins also have harmonics. A little Tweety bird will just be one little line. They don't have any of those harmonics. They're very pure tone. But these inhale squeals, they have harmonics, but they're way up here. And what you actually have are two separate notes. And what it turns out is birds, unlike people, have a syrinx, not a larynx. And a syrinx actually has two parts. And so you actually have two vocal structures. And so each of those lines is one of their vocal structures. And the thing is that I covered it up with these lines, but they don't have to match. The bottom one here starts before the top one, and they overlap. So they can cross each other, start at different times. But it's just one of those interesting things about those inhale squeals that I've been discovering. So I've been measuring this, and what I learned is that when you compare a bird when it first arrives at the colony, and you record it again days and weeks later, that bird still sounds the same. All right, you're still able to correct. If I take one call out of my grab bag of calls, I can still correctly assign it to the right bird, even over time. And so you don't have to understand any of that, but it should show you that it doesn't change. The bird sounds the same on day 1 as it does on day 28, even after it's lost half its body weight. And so then I decided, well, what about from year to year? So I recorded some individuals from year to year, and over the course of 4 years, there was no difference. The bird sounded the same in year 1 as it did in year 4. And I did this all through the magic of statistics. All right? No real birds were involved in this. So what I did, I learned from this is, yep, these birds have individually specific signatures, which means that they are very consistent within an individual and different between individuals. And what that allows then is a theory that you can code information on identity and quality. All right? So now I've got the theoretical foundation and the magic of statistics. And using that, I can tell 97% of my calls apart by bird, which is very exciting because we all make mistakes and I type wrong and things. All right? But the thing is, do the birds actually tell each other apart? It's one thing for, to use a statistics program. It's another thing to see if the birds really do that. And so what I did is I did several playback experiments. And I have a little Tweety bird up here. And it's, one's in case you like Tweety birds, which I really do. This is a song sparrow. But these are classic experiments where you play to a bird the sound of its mate, a neighbor, and a stranger, and you see how it reacts. Because if it can tell them apart, it should react differently. And so what I did is I played calls of an individual, its mate, a neighbor, a stranger, and then I played parent calls to chicks. I did 3 major experiments. In the first one, I played the male advertising call to adults, both members of a pair at different times during incubation. And second, I played the duet call to both members of a pair at different times. And third, I took the duet call of the parents and I played it to the chicks when the parents were gone to see how they would react. And so again, this is the male display call. And what I found is when I played the male display call to a female, her mate's call, and that of a neighbor and a stranger, these were my results. And you don't really have to understand the stats or anything about this, but you can see that the response is higher. And what this is, 0, the response score there on the up and down side, 0 means the bird did nothing. It just sat there when I played my call. And 7 means that it ran out of the nest and started calling and flipper patting the speaker. All right, it was very excited by this call. All right, and in between, 3 means it looked around for 6 to 10 seconds. What was that? So it was a very strong response. Females were very excited by the sound of their male's voice, and this would make sense. I mean, after all, she's been sitting there. She's been hasn't eaten in a month. She's waiting for her mate to come home. She's starving. If he doesn't get here soon, she's going to have to abandon her eggs. The thing that she wants to hear is the sound of her voice, her mate's voice. And I always feel a little unkind, messing with their minds a little bit. But it's for science. Now, when I played the same sequence of calls to the male, which meant it's his call, his own call, the call of a neighbor and a stranger, no difference. All right, statistically. All right, they didn't care. I mean, why would they? They're incubating their own eggs. Why would they care if somebody's advertising for a mate? All right, so it makes sense. Now, I did the same experiment using the mutual display calls, the duets. And what I found is when you play a call to a pair, a member of a pair, it gets very excited. All right, but if you play a stranger call, it doesn't draw near the response. They're much more excited. And because that call is overlapping, I could never tell if separated whether they were most excited because their own voice was there or because of the voice of their mate. I'm assuming it's the excitement of hearing their mate's call. Now, I thought, okay, I got great results. This is good. I can get published. But the thing is I thought maybe other things were also going on. Maybe the weather affected it, or maybe how long they'd been away from their mate, and I checked 11 or 12 different variables that might have affected my results. And I just want to point out the one that was the most interesting. In this graph, you don't have to study it hard, but what it basically tells you is that the longer a pair has been mated, the less exciting the female is. All right? And I don't want to draw any conclusions here. This is just data. This is science. All right? So you draw your own conclusions about why females get less excited the more years they've been mated. Now, with the chicks, we played, again, that duet call of their parents, because that's the one that they when they sing when they reunite at the nest. So it should be important to the chicks. It means both mom and dad are home. All right? And when I played this call to the chicks, a very strong response. The chicks got very excited by hearing their parents call. All right? So that was all happy. And so what I was able to show is that penguins indeed tell each other apart by voice, even if they can't tell each other apart by sight. But then the big question I was trying to ask was, can females tell anything about a male, his quality, just by his voice? Yes, they can tell apart. Yes, I know that's my mate, and I know that's not. But can you say, yes, he's hot, and he's not? All right? And so what I did, okay, and then I've got a little tagline here. I mean, if someone calls you on the phone, I mean, would you be more excited to hear Bond, James Bond, or Pee Wee Herman? I mean, I don't want you make your own choice. All right, so what I did is, remember I did all these measurements. I exhausted myself measuring these calls. And so I thought I can use these again. And so what I did is I took other parameters of sort of substitutes for male quality, because it's kind of hard to say what is a quality male. All right, so I used some proxies like age, body size, body condition, how long they'd been fasting, what their nest quality was, their mating success, how many mates they had, reproductive success, how many eggs, how many chicks they were actually able to fledge each year, what their divorce rate was, and then I had some data on their immune function. I had drawn blood samples and had done some immune tests. So I had these parameters. Now, I'm actually defending my PhD dissertation 3 weeks from today, and I'm not done. So this slide isn't ready, but I do have some preliminary results. And what I have found that indeed there are differences. Older birds sound different than younger birds. In fact, I always knew this. When you have an old bird, it's got a band that says like 007 out of 55,000. This is an old bird, all right? But it sounds like they've been like chain smoking, all right? So they sound sort of like these short, raspy calls. And so I always thought that was true, and now I have the science to prove it. They smoke. But younger birds have different parameters than older birds, and smaller birds sound different than bigger birds. And I'm teasing out some of the more subtleties, which you ask me in 3 weeks, and I can give you a really long, complex answer, I hope. All right, and the last thing I want to talk about is penguin conservation. And this, what you see here, one is from New Zealand. Little blue penguins come in every night. They don't go for, like the emperors, for months at a time. They go out to sea every day and come back at night. And unfortunately, around most of New Zealand, they've built roads right along the coast. They're beautiful coastal roads, but it's a problem for penguins, and the number one cause of penguin death is car hits. Because they come up during the night and they cross the road to go up into the hills to their nests. And so they have these signs that says, slow, penguins crossing. And on the right, you've got a structure built for a yellow-eyed penguin, which I mentioned is the New Zealand endangered species. And their big colony actually burned a few years ago, and so they supplemented with human-made structures. Now, I'm also concerned because remember I told you that I study at Punta Tombo, the largest penguin colony outside of Antarctica? Well, we do a survey twice a year at Punta Tombo, and there are 500,000 penguins there. But it's slowly over time, this has been decreasing. You see there's a big dot over here. And that was a year of a massive oil spill. All right? And you can so there very few birds relatively were breeding then. This is the year that Jenna Sigmund from the New England Aquarium helped. You draw your own conclusions again. But over time, this little red line, it doesn't look dramatic, but when you calculate it, it's a 25% decline over 20 years, which means well over 100,000 penguins have disappeared in 20 years, and that's dramatic. And it's a great cause of concern for us. I mean, there's no question. There are lots of penguins at Punta Tombo, but there are fewer of them and fewer every year. And so we've been working very hard on conservation issues for our own species as well as other penguin species. The traditional threats to penguins were direct consumption. This is a penguin melting pot in the Falklands. Penguins are, well, they're fat. And they're full of oil. And once the whales were mostly wiped out, they switched to penguins because you just throw a bunch of penguins in this boiling water and the oil floats to the top and you can collect tremendous amounts of oil. It's not as good as for like emperors and kings, of course, were the favorites to boil down. But they were a source of oil. They were also a great source of food. If you were a Magellan and you're coming down the coast and you haven't had fresh meat in ages and you're going out to sea, just throw a few dozen penguins in the boat. They can't go anywhere and they can fast for weeks at a time. And you have fresh food. It was incredibly wonderful for them. And the same thing when they discovered tortoises. You just throw them on their back and leave them in the boat for weeks or months at a time, and they're still fine. And people like the eggs. All right. All mainland penguins in South America had been wiped out. Is pretty much what we believe after humans arrived down 12,000 years ago, and they've slowly been reappearing. The colony I study at, Punta Tombo, had no penguins in 1920. It was traditionally a big penguin colony, but there were none in 1920. But the people stopped persecuting them. And so once the ranchers left them alone, all of a sudden the penguins started reappearing on the coast, not just outer islands. Another reason we begin this study is what you see here is a penguin wallet. And a Japanese corporation had applied for a permit to begin harvesting penguins at Punta Tombo for golf gloves and wallets. The government was considering granting the permit. And this was during the year of the Dirty Wars, and nobody said anything to the government in Argentina at that time, if you know anything about your politics. Nonetheless, the citizens of Chubut, Argentina, and actually the entire country, went up in arms and said, nobody is going to kill our penguins for wallets and gloves. And it wasn't sure that they could sustainably harvest them. So the study that I'm part of began studying the penguins to learn whether or not you could sustainably harvest them. And since then, nobody's ever tried to apply for a permit, but that was the impetus for this long-term study, was a response to that threat. This says Guano de aves marinas. It's, marine bird poop. All right, and this was harvested heavily for nitrates, which was used in gunpowder. And during World War II, much of the world's supply of guano was harvested for ammunition. And why is this a problem? The problem is that Spheniscus species, the African, the Humboldt, the Galapagos, and the Magellanic, are burrow penguins. They dig burrows. And what did they traditionally burrow into? Guano. This guano was 6 to 20 feet deep in most places, and it was from other birds. And it's easy to dig into. It's waterproof. It's fabulous. I mean, there may be an odor problem, but you can't have everything with real estate. And so that actually has been a tremendous impact negatively on most penguin species of Spheniscus. And so in Africa, this was actually an area that was completely mined for its guano. And these African penguins, remember, they're in the heat of the desert. Have nowhere to nest. And so the conservation efforts there, they're trying to provide artificial housing to protect the African penguins. Also, fishing, competition with fishing. Not just getting caught in nets, but actual competition for fish. Now, remember, I mentioned anchovies being the Spheniscus species, like the Magellan and Magellanic and the Humboldt. It's their favorite food. In Peru, 98% of the anchovy fishery is harvested every year. And that was the #1 food for Humboldt penguins. Humboldt penguins are a threatened species, and primarily because there is no food for them. Now, on the east coast of South America, there is no anchovy fishery until this last 2 years. Because all the big fish are gone, we've been fishing down the food chain, if you're familiar with that concept, there's now starting to be a developing anchovy fishery on this side. And we're working hard to control it in some way, because if the anchovy fishery reaches the size of the anchovy fishery on the Pacific side, Magellanic penguins are going to be in serious, serious trouble. Now, we have been tracking penguins by satellite, and we put these little tags on them, and they tell us where they go. And what we thought that when they were gone for 2.5 weeks or so out to sea, or a week and a half, they were going out 30, 40 kilometers and catching some fish and hanging out and refilling their supplies. But when we started tracking them by satellites, that's when we discovered they were going up to 1,000 kilometers away during that 2.5 week period. They're going north again to meet the anchovies, which are migrating south. And so we actually talked the government into setting up a 30-kilometer reserve around these penguin colonies. Well, and it turns out that once you know the science, they don't even stop in those 30 kilometers. They're headed out. And so effective management, 30 kilometers won't do anything. We also convinced the government to shift the shipping lanes for oil tanks. Argentina is self-sufficient oil-wise, and all of its oil comes from Comodoro Rivadavia, which is also in Chubut, the same place where Punta Tombo is, but at the very south end. And they take all of the oil by boat up to Buenos Aires, and they go right past Punta Tombo. And so there's always been a lot of oiled penguins. We convinced the government to move the shipping lanes out further, away from the penguin highways, because you can see they tend to follow similar paths, and that has been tremendously effective. Because oil for penguins is a disaster. Remember, these are waterproof birds. It's cold water. And if even an oil spot the size of a quarter, which is a drop or two of oil, means that you can't thermoregulate. You get cold because the water's touching your skin, which means you have to go on dry land, which means you starve to death. And if you have a lot of oil, you'll ingest it, and it's toxic. And so a bird like this, it will not make it. There's also a new problem that seems to be developing is more and more red tides, or toxic algal blooms. And what you see here is a penguin that has thrown up its squid. I mean, yeah, can you imagine that it threw that up, for one thing? But we went, free food, because we were trying to supplementally feed some chicks. And so we grabbed the squid and cut it up and fed it the chicks, which immediately started spinning in circles and threw it up. And we think that it probably was toxic. Like, they have shellfish warnings, don't eat shellfish. It's the same kind of thing. And you see the drunk penguins. And this year at Punta Tombo, there are a lot of drunk penguins, and it seems to be like there's a red tide happening this year at Punta Tombo. And that they seem to be happening more frequently, which may be related to global warming. Another threat is ecotourism. Now, at Punta Tombo, we get more visitors than the Galapagos Islands. We get up to 80,000 visitors a year in this short breeding season. And we have fences for the tourists. And we wind them through this little fenced area. And it works really well. They breed, the Magellanic penguins breed in the tourist area, and they breed just as successfully as birds outside of the tourist area. They've adapted very, very well, and it's worked extremely well. It's considered a model of successful ecotourism. Unfortunately, they applied the same model to the sister species, to the Humboldt penguin. Unfortunately, Humboldt penguins don't acclimate to people. They see people and they run. They abandon their eggs in their nests. And that's been a bit of a disaster, but there's been a huge tourism industry that has developed for Humboldt penguins as well, but it's been a disaster for those birds. And then the last thing I want to talk about a threat is global warming. And everybody talks about global warming. But you see this lovely iceberg, snow, penguins. This picture is all wrong. These birds should be nesting on bare stones and gravel. But you see snow. And one of the byproducts of global warming is incredibly increased precipitation. Technically, Antarctica is a desert. It gets very little precipitation. And so with increasing rain and snow, it's very much changed the character of the land for breeding penguins. This here, I don't know if you can tell what this is. That's the eye of an Adelie penguin, which has been buried in a snowstorm. And normally there would be no snow at this time of year. And what happens in this picture, these are also Adelies. You can't really see it very well, but what has happened is a lot of snow, and it melted. And this right here is the egg, which is about an inch under frozen water. And that egg will not hatch. And rain just doesn't work well for most penguins. Now, even at Punta Tombo, it's a desert. We've been getting more and more rain. And rain, of course, as you can understand, is bad for both eggs and chicks. In fact, you can predict 50% of the variability in reproductive success just by asking how much did it rain. All right, so rain is a disaster for penguin chicks at Punta Tombo and for eggs. But it could in part. It could in part, not in whole. We think it's a whole combination of things, but very likely in part that's part of it. We have some really successful years and some years that are disasters. But I want to end on a positive note. And so what I want to do in these last couple of moments is to, these are Little Blues, and I'm just going to play a few penguin songs. Oh, that's so beautiful. All right, and here, Adelies. and gentoos. And some of the famous ones here. And of course, just want to end with a picture of our hero, the Magellanic penguin. And to thank some of the folks here, Vicki and Heather and Jenna, and the folks back in my lab in University of Washington, and then, of course, the really important people who pay for everything over on the right there. Thank all of you. And I want to thank you for coming tonight.